All right, so welcome everybody to the third lecture. We are now halfway through, or after this lecture, we're halfway through. And today, okay, so maybe just to do a quick recap of what we've covered so far. So in the first lecture, we talked more of the qualitative aspect of valuation. And then in the second lecture, we covered 4 tools that assist us in the quantitative component. And they include, the DDM, FCFE, FCFF, and RI, right? Residual income model. So those are the 4 tools that we have learned on the quantitative side. So in the next 2 lectures, which is today and the next week's lecture, so lecture 3 and lecture 4, we'll cover in detail more of these quantitative tools. So in this lecture, we are just focusing on DDM. And the next 2 lectures, we'll talk in detail on the RI, FCFE, and FCFF, right? So we're going to tackle some more variations in terms of the valuation method today. Okay, so let's have a look at what we have. So when you think about dividends, and I think a good question is, when do we use DDM? And I think the textbook mentioned that if it's less than the cash flow generated by the FCFF, right? So you will see that there are more criteria later in the lecture on when to use DDM or when not to use it in that context. So to first understand, let's go back to the basics, right? So there are various growth stages to dividends. So you have the high growth, normal growth. Let me just pull out my pen. Give me a moment. So you have your high growth, normal growth, and no growth, right? And they kind of mimics the business or the various cycles, not really cycles, but the life cycle of a company. So when you think about high growth, you typically think of, maybe it's like a startup, they just started business, maybe revenue is growing very fast, but at the same time, because it's like a startup, they need a lot of investments, and therefore most of the time they either pay very low dividends or no dividends, right? So this is something that is like a characteristic of a high growth company. In terms of risk level, as if you measure it as a startup, you would think that, because it's a startup, risk is high, possible closure if the business model doesn't work, right? So that's a more high growth company. Now, in a more normal growth, that's where most of your blue chips company falls into, and you can think about it as like more of a mature, not really mature, but like growing, but then they are quite stable already, right? So in terms of the growth, it depends on things like when we talk about in the first lecture, what are the barriers to entry, what are the kind of competition you have, you can affect the growth. And of course, in the normal growth, the growth rate would decrease to the normal level, right? So from let's say high growth, maybe it's like 12%, like the G equals to 12%. So I hope you remember sustainable growth rate. So let's say the G is 12%, maybe the normal growth is 5%. So there's a drop to a normal growth level. Of course, the company continues to grow. Investments are needed, but maybe at a lower level. The amount of dividends paid will be, of course, higher. Now, what's important, and this is something that you probably need to realize, is that for a no growth company, right? So that means there's no further growth in the revenue, no further investments required. The company will pay all of the earnings as dividends. So this is an important characteristic. So, when we look at questions, in case they say, this is a no growth company, so you got to immediately know that, okay, if it's a no growth company, it means that's going to pay everything, all the earnings as dividends. What does this mean? It means that the payout ratio would be 100%, right? So there's zero retention ratio because everything's been paid out, right? So these are important characteristics, that all earnings are paid as dividends for a no growth company. And of course, because it's a very stable company now, the risk level is usually quite low. All right, we'll look at one question here in a little bit later down the slides where they just say it's a no growth, and then you need to know that the characteristics is that all earnings are being paid out as dividends. Okay, that's a good question. So the growth rate, what does it base on? So I hope you do recall your sustainable growth rate. Anyone can remember what's the formula for sustainable growth rate? G equals to, anyone remember? G equals to, what is it? Yeah, that's correct. So B is the what's retained, right? Retention rate. So because you have ROE inside, right? So you have ROE, return on equity, and remember the decomposition of ROE using the DuPont formula. So yeah, there is an impact on either sales and also net income on the ROE and hence the growth rate. So let me just see. Okay, in the subsequent slide, we'll show three methods to calculate the growth rate, or not really calculate, but how growth rate can be calculated. But the typical method is to use the sustainable growth rate formula, which G equals to B times ROE. And so to answer your question, the growth rate do not only based on the revenue and sales or net income, because we have the decomposition of ROE, which we see that the growth rate can actually be impacted by the leverage. Remember, ROE, because you're decomposing the ROE into leverage, it can be based of course on the sales profitability, right? The profitability ratios, your solvency ratios, and your liquidity ratios, right? If you do recall your DuPont. So there are three components that actually affect your ROE. Yeah, correct. Retention ratio. And you recall retention ratio is 1 minus dividend payout ratio, right? Because whatever that is paid out, that is not paid out is being retained. Yeah, that's right. So that is the basis of calculating your sustainable growth rate, or G in this case. And when we talk about growth rate, it's always this sustainable growth rate G using this formula. So, all right. So going back to dividends, thanks for the question. Going back to dividends growth stage. So this is just a quick summary. Again, I want to highlight this is an important component because this is a characteristics that you need to realize exists, right? So no growth means 100% paid out. This is just a graph showing you the various stages of sales as the company grows. Right, I'll just move on. All right, so let's just quickly have a look at three different types, or actually four different types of DDM models. And I want to highlight to you, understanding these four different types of DDM is very important, because in the next lecture, when we talk about the FCFF, RI, FCFE, everything falls back on the understanding of this model, because they all use the same model, just that they just change the number, right? You change it in the sense of, oh, now instead of using dividends, we use free cash flow to equity. Instead of using free cash flow to equity, maybe we use free cash flow to firm, or maybe even we use the residual income, right? So, but everything is based on the understanding of this basic model that we're going to talk about. So, I encourage you, if you do have any question regarding the models, like or why is it using this calculation, etc. As I explained, do stop me. Feel free to type in a group chat, or unmute yourself as well. That's fine. Okay. So now let's think about a single stage model. So this is the most basic model, probably something you have seen before, right? So a single stage model can be either when the company will not grow or growing at a normal rate. So I like to use a graph to actually show you what it means. Later you understand why when we try to solve a few questions, right? Because you need to be able to picture how it looks. So in a no growth, so we are plotting a graph of G growth rate in the y-axis and t, right? Time in the x-axis. So in a no growth, obviously no growth means do not grow means g equals to 0, and so the line is like this, right? On the x-axis. Now, if it's a normal growth, means that and normal and stable growth means that it's just flat, right? Anyone can recall if it's a stable growth like this, okay, so go back to no growth first. A no growth, what kind of formula will we use to do this calculation? Like before even I talk about what formula, but we kind of touch a bit on this. If there's no growth, what kind of formula should we use to calculate this the firm or the valuation of this firm? Yeah, that's correct. Perfect. Thanks for answering. So that is the formula for a perpetuity, right? Yes, perfect. Yeah, that's right. Because there's no growth, no G. So it's a perpetuity formula. Perfect. If it's a stable growth, what kind of valuation model, not model, but formula should we use? Yeah, that's correct. So the one yeah, that's correct. So basically is the growing perpetuity formula, right? It's called stable growth means that it is, yeah, perfect. That's right. K minus G, which is also R. KE minus G, which is also R minus G. Perfect. So as you understand, if it's a no growth, means it's a perpetuity. A stable growth at a stable rate is just a growing perpetuity. All right. Now, of course, companies do not grow like this all the time, right? So we have this two-stage model where the company has a high growth at this point here, right? Let's say this is 12%. And then suddenly it drops to a normal growth, right? Maybe let's say this is 5%. Now, in terms of this, can we try to dissect how do we calculate these two components here, right? In the first component, let me just use this color state. In this first component, how do we calculate this part here where it's growing at a high rate of 12? Just intuitively, like before we look into the formulas and everything, but intuitively, how should we do it? Let's say this is for 5 years, right? 5 years. So in the first 5 years, what we can see is, can you just see that it is simply doing a annuity, sum of PV. Okay, sum of PV is correct. You can do a sum of PV, or you can use a growing annuity. Anyone still remember a growing annuity? Remember we touched about it in lecture 1. So you do sum of PV, that is, I guess, the easiest method since you have Excel to do it. In case, you want to flex a little in your exam, you can use a growing annuity as well, right? Because you have a growth of G. And remember what's annuity? Annuity is a stream of cash flow until a certain number of years, right? In this case, 5 years. So PV and PV of it at a high, okay, that's correct. So PV at terminal, so what we are calculating here in the first component is the PV at the high growth stage, right? So you can do a sum of PVs, right? 5 years. So 5 cash flows, right? If it's a yearly cash flow, 5 cash flows back to year 0. Now, the second component here, right, it is where you have your, what you call your terminal value, or in this case, it is your growing perpetuity, right? So that means let me put GP, growing perpetuity here, right? So going back to your stable growth, where it's just a growing perpetuity. Okay, so it's 2 components here. So sum of PV or growing annuity plus your perpetuity, right? So you can see there's 2 different formulas here. Okay, so this is a simple 2-stage. later we have some calculations, right? Yeah, you have a question? Accidentally unmute.
老板要
不对，多吹吧。
Okay, I think maybe it's accident. Let me just move it back. Okay, so sorry for the disruption. Okay, so now we go back. Now the third model we think about is this two-stage model, two-stage H model. So this H model comes about in the sense that what we saw just now when there was a sudden drop in the growth is not very natural, right? So in most cases, there is a gradual drop. So this is the part where it gets a bit tricky already. So it drops gradually, almost like a triangle, right? It just like drops directly and then it goes straight. So it declines kind of linearly in this regard. And we'll see how to calculate this. Okay. Last but not least, we have the three-stage model. But I would like to highlight that it's not in the syllabus, although we just need to mention it, not in the syllabus, in the form of calculating using the various formulas for this three-stage. It's not part of syllabus, but knowing that it exists is too important, right? So in the last question of this lecture slide, for self-practice question, there is a three-stage model which I'd like to cover at the end of this lecture, and I'll just go through it more for understanding, simply because it is actually just piecing together various components like what we did just now, right? Find out, okay, is it a perpetuity or is it growing annuity first and then plus something, right? So in this sense, the three-stage, we can see it in this form. So you add three things together. And this is, I would like to say, this is the general formula for a three-stage. I would like to highlight again, this is not in the syllabus, but knowing it exists, you do need to know that it exists, right? So basically, you add the PV at the high growth, the transition stage, and the normal growth, right? And the thing is, let me just flip back to a three-stage. If you notice, what you can do is you piece together the formulas like this, right? So in this part here, this is a H, two-stage H formula, H model, right? And then from here onwards, it is like another part of a H model. So that's how you actually construct this valuation. So you basically piece together components of it. Another way to see the three-stage, this kind of three-stage P, is that you see this as a sum of PVs, like what we talked about earlier, right? And then plus a H formula here, two-stage H formula, right? So we can, yeah, this is just for you to understand. Three-stage, okay? Okay, let's go into detail of each type of DDM valuation now. Going back to the most basic again. So the single stage, no growth. Okay, so for single stage, no growth means that, remember when we talk about the three different stages of dividend growth, when there's no growth, what happens is that dividend payout ratio is 100%, right? The characteristics that I mentioned is important to know. And all earnings will be paid out as dividends. Okay, fine. No growth in dividend payout. Yeah, zero growth. And the valuation is a PV of a perpetuity. And this is the formula for no growth. So there is an important note here that the first payment starts one period from today. Now, this is a characteristics of the perpetuity formula, but in this sense, because there is no growth factor here, the C does not change, right? C or dividend, the D does not change. Whether it's D, so the D0 will be equals to D D1 equals to D2 equals to blah, 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 D3, D4, because there's no growth. So in this sense, it's kind of not very important whether it's one period for today, but I just want to highlight that this is a kind of standard formulation of a perpetuity. But as you know, in a growing perpetuity, this makes more sense because whether it's a D0 and a D1, that the values are different. Okay, so in terms of the returns, so there are two kinds of returns whenever you hold a stock. You can either get a dividend yield, right? When you hold a stock, you get dividends, or you get capital gain, right? So you usually get a mixture of both. Now, if the company has no growth, right, the capital yield is zero because there's no growth, right? The company is not growing. Means all the return comes in the form of dividend yield. So this is another way of understanding it, right? So when you hold stock, it can be either dividend or capital gain. But if there's no growth, means there's no capital gain yield. So everything comes from your dividends yield. Okay. Now, the second a bit more second kind of valuation is a stable growth, as we talked about earlier. And means what? Means the earnings of the company is expected to grow at a constant rate, or G can be 12%, 5%, etc. for the long term. And the dividend, there is this assumption here that's important, that you need to assume the dividend payout ratio is kind of constant over time. Okay, and the dividend payout ratio, because it is growing at a stable rate, they need investments. They need the money to do various kind of investments, etc. They cannot pay out 100% in terms of dividends, right? So because of that, they pay out less than 100% as dividends. Okay, so the stream of cash flow grows forever at a stable rate. And because it's growing, we just use the PV of the growing perpetuity. Okay. So this is just a recap. You already saw this slide in the last lecture, where we talk about the base formula of a stable growth dividend discount valuation model, right? So it's DV1 R minus G. Of course, the assumption is that G must be less than R, because if it's the other way around, where G is more than R, you get negative and you basically can't use this formula anymore. All right, so this is a small recap on the sustainable growth rate. So the sustainable growth rate is the rate where a company can grow without resorting to external financing, the rate that the company can grow with using only funds that are generated internally from its operations. And there are three estimation methods. The third one, using fundamentals, this is what we have been talking about, where G equals to retention ratio, which is B times ROE, right? And alternatively, usually you can use things like, historical data, what's the historical growth, maybe you take a simple average, or it could be things like, what is the analyst forecast, right? So, or it can be a combination of three approaches here. It can be a combination of three. Maybe you do a comparison between the fundamentals, maybe you do check with the historical, and last but not least, you can actually moderate the growth rate based on the forecast or the analyst forecast that you suspect. So this would fall back into, when you do your valuation report for your GBA. So think about the sustainable growth rate. Maybe even try to go onto, FactSet, if you have access to Bloomberg, etc. To just have a look, right? Sometimes they do post such information, and then you can even calculate the sustainable growth rate using this formula, and then you do like a check, right? So what growth rate to use? At this point, I also like to highlight that if you notice the formulas, let's say this one, where there's a stable growth, predicates a lot of emphasis on this G component. So calculating the right G component is very important, because you calculate it wrongly. Let's say you say the growth is very high, of course, still less than the R, it will actually affect the your valuation, right? Your P0 valuation of your firm. So calculating the right G is very important. I want to highlight that if you kind of remember what we talked about in lecture 2, comparing between the 3 methods, DDM, FCFE, FCFF versus RI, the difference is quite distinct, right? Remember, RI is based on more balance sheet, where a lot of the value is placed on the book value, and it add the RI in, right? But then for the 3 other methods, a lot of weight is placed on the terminal value, TV, and typically the terminal value is based on G, right? So that's where, because it's terminal value usually based on a growing perpetuity and based on G, and that's why calculating G is important. There are some assumptions when we use this sustainable growth rate. Good to know in terms of, profit margins must be constant leverage ratio, and a stable dividend policy. Of course, in real life, this does not always hold. That's why there are 3 methods, and usually we try to do an average, or we try to, choose one method over the other. All right, so just a bit more details on the sustainable growth rate. So if G is the growth rate of the company is more than the optimal sustainable growth rate, it means that the company is growing faster than what it's supposed to be growing, right? It means that perhaps they might have some kind of cash flow problems because they are growing so fast, but it's not sustainable, right? So if they do have cash flow issues, things that they can reach out or go for include some external kind of financing, whether is it through debt or equity, to make sure that the cash flow remains stable and sufficient. So this is just a small comment, that internally generated funds, usually in the form of like equity distribution, is typically cheaper compared to debt, because debt you do have a lot of administrative things that you have to do. Reach out to a bank. If you want to tap onto the bond market, you have to go through various procedures, prospectus, etc. So generally, internally generated is kind of cheaper, although usually for debt, you do have some benefits of tax incentive, right? So you have your tax shield for your debt. So what you can do, of course, you can prune away some marginal activity that are non-core and concentrate on highly profitable. So this would make sure that your growth rate is moderated downwards. Maybe you can do some outsourcing of production at a lower cost, or you can merge some cash cow components or business segments that are growing at a lower rate and the optimal growth rate. So this is some theory. And on the flip side, if the growth rate is less than the optimal growth rate, what can we do here? So we can distribute some excess cash to a shareholder in form of increased dividend or kind of share buyback, or you can purchase a company that has a higher growth, right? So you purchase a company, do a M&A, merger and acquisition, and boost your company growth. So this is just a small comment that no company actually really grow at a constant rate. So however it takes along, what we can do is we take a historical average many years, and we calculate what is the average growth rate of the company. All right, so now we have a small example for the stable growth dividend DDM valuation. So let's look at this question here. So we have a company, JCPenney stock, and the required rate of return for this JCPenney is 8.8% using a CAPM. So they calculate the return equity for you already. On examination, you believe that it's a stable growth, okay, of 6%. So G is 6%. All right, and the company currently pays 50 cents. Okay. So we can use the DDM model to value this stock here. Right, the answer is here. So because it's a stable growth, we can immediately think that, oh, right, so it is a growing perpetuity. All right, so let's just quickly see here. The thing to highlight is that this company currently pays dividends of 50 cents. Currently pay means this is a D naught. Everyone got that? So it's D naught. So when we use the growing perpetuity formula, because growing perpetuity formula is a D1, so we need to multiply it by 1 plus G, and we know G is 6%, then R, and we take R minus G of 6%, and we should get the answer here. All right, everyone got this? Why we multiply by 1 plus G? Yeah, okay. Because it's the main word is current, right? If they say next year's dividend, then there is a D1. All right? Okay, that's good. Perfect. So we have now calculate a very simple valuation of the stock. And it's $18.93 here. So now the part two say the current stock price, the current price of the stock is $25. Using your answer in part one, state whether this stock is fairly valued, undervalued, or overvalued. So now you calculated it at $18, right? But the current market is 25. Means what? This stock is overvalued, right, by the market, because it's supposed to be cheaper, right? Yeah, that's correct. So typically what should you do when you find an overvalued stock? You sell or you buy? Yeah, you sell, correct, because it's overvalued, right? So you want to buy something that's undervalued. So yeah, you should sell this stock because it's overvalued at the moment. And of course, when you sell a stock, you make a profit from it. Okay, so we have another question here, very similar. So again, what do we have here? The company is profitable, it will pay this dividend next year. Okay, so this is important. So this is really a D1. Because it's depleting its my property, the best estimate for its dividend will decline. So we are looking at a negative G. So G equals to negative 10%. Okay. Required rate of return is given at 12%. What is the value of the share? So again, we simply just plug all the details into a growing perpetuity formula. Do take note that this is a negative, and therefore you get this valuation here. So I'd like to highlight at this point in time again, why are we learning all this detail for dividend DDM valuation is at the end of the day to do a valuation of a company, right? And the thing is, while you do see some examples like this, and later in your self-review questions, you do see some practice questions. Typically, yes, in a TMA, you do see some of these kind of questions, but, let's say in your finals or even, GBA, you will not really see this kind of problem questions, right? Because what we are more interested in is actually, can you actually do a valuation of a company? Right, so these are just more to give you the skills to use this formula. So we do have one more question here for again a stable growth. Okay, so now this one gives you a bit more detail, so it's not so straightforward. So what we have earning of 15 million in 2008. It has 5 million shares outstanding. Fine. It retained amount of 6 million, so we know the retained earnings, right, for the year. And its equity at the beginning of 2018 is 60 million. So there's quite a bit of information really. Earning is expected to grow at a sustainable rate for a long time. Okay. So once they say growing at a sustainable rate at a long time, we know that we will have to use the stable growth formula. So while this question is placed under stable growth, of course, most of the time questions will say this is a stable growth model, right? So you need to pick up the information that, oh, okay, it's expected to grow at a sustainable growth rate for a long time, which means stable growth. Risk-free rate is estimated at 4%, risk premium 7%, data of this. So immediately you know that this information here is basically your CAPM, right? Used to calculate CAPM here. All right. Okay, so estimate the value per share and what is the value of growth. So this question is interesting because there is this component called value of growth here. And let's see how is it being done. Okay, so we are given quite a bit of share information, right? The earnings, our share outstanding, retained, amount retained, and equity amount. So because of this, we have to calculate the growth rate because it's not given to us what's the growth rate. And I hope you do recall, you should recall because we just talked about it, G equals to B times ROE, right? So now, how do we calculate the D, which is the retention rate? So what we can do is that, first of all, we can, let's see what information we have. Amount retained is 6 million. So if they retain 6 million out of the 15 million, so that's where we can calculate 6 divided by 15, we get a retention ratio. We can calculate what is the dividend payout, because dividend payout is just 1 minus retention ratio, even though actually, and then after use this dividend payout, we multiply by your earnings per share that we calculated, right? Because then we can calculate what's the dividends per share being paid out. All right. We can calculate what's ROE because remember our goal is to calculate G. So ROE, we basically take your earnings divided by equity, which is given to us. What is our earnings? 15, which is here. And our equity is given at 60, right? So ROE, 15 divided by 60. And we calculate what is G, which is the retention ratio, which is what's D here, retention ratio. Let me just use this color. So it is the retention ratio multiplied by ROE, which is what is given by this formula here. Okay, so once you calculate G, which is, I guess, the toughest part to calculate in this question, we can use CAPM model, like what I highlighted earlier. This is the CAPM here, right? Use CAPM to calculate your cost of equity. And after that, we simply plug in the formula into a growing perpetuity. And again, I want to remind you that your dividends per share, 1.8, is your D naught. So this is D naught, means that you need to multiply by 1 plus G, right? So it is usually, this kind of questions that kind of get you tripped over in terms of this D naught here, which is why, I try to emphasize that. Make sure you know, is it a D naught or is it a D1? Maybe I'll pause here. Any questions regarding this example, part A? No. Okay. All right. Then for part B, what is the value of growth? So we know that if a company is not growing, remember, when there's no growth, what happens? It pays out everything as dividends, right? Remember, that's the characteristics that I told you about. So if it pays out everything as dividends, it is, what do we do? So we just take a perpetuity, right? So take a perpetuity means no growth. So it pays out everything as dividends. So we take the 3 divided by what we calculated as the return on equity. So C divided by R, 3 divided by 11.7%, And we get this for the value of a no growth stock. And we can find what's the value of growth here. So we just take this minus this, get this, right? So this is the value of the growth factor. All right, so now let's look. So we have tackled the more of the simpler aspect of your dividend discount valuation or the DDM valuation. Now let's look at another one where we do a simple two-stage where it's just 20% and it just suddenly drops to 8%, right? So there's the question here where it says that, oh, you know, for the first 3 years it's 20%, and then it falls sharply a growth rate of 8% thereafter. They are quite nice to you. They say D naught is 1.8, cost of equity is this. So typically the question will not give you a graph like this. And I usually encourage you to draw a graph if you can, so you can visualize. So in this model, as we mentioned earlier, it's just two components, right? So, I mean, this looks a bit complex, complicated, but it's more of an explanation where you just simply take, it's just two components. Let me just write it here. It is the PV of cash flow for 3 years, right? Plus what? The growing perpetuity, GP, growing perpetuity. So it's just basically two components, component 1 and component 2, and you add them up together. And this is what we're going to do here in this example. So in component 1, again, like I mentioned, you can either use a PV or sum of 3 cash flows, or you use a growing annuity, right? But in this case, let's do the simpler method. We use sum of 3 cash flows. So we have dividends in D naught, given that we have D1, D1, D2, D3, and then we just multiply by the growth factor, right? But remember, we need the PV of this cash flow, so we just do a PV here. So this is basically the PV of the 3 cash flows. Okay, now, after you have done the PV, so calculate the dividends, we calculate the, after we calculate the value of the dividends on the 4th year, right? Then we do a discounting of this 3 cash flow back to year 0 to give you the value of firm for the first 3 years, which is what we have done here, 0.3. Okay. Now, we know that from year 4 onwards, or not year 4 onwards, sorry, from year 3, after year 3, the company will grow at a stable rate. And this is where we calculate the terminal value, TV, right? And we use the growing perpetuity formula to do so. So let's take this line graph here, and we see that, okay, so we are in year 3, we are year 3 here, and we know at year 4 this is the amount of dividends in paid here, right? So remember, your growing perpetuity is that it's 1 period from today, right? In terms of formula. So we are standing at year 3. Let me use this color. We are standing at year 3. We use the growing perpetuity formula to calculate what is the terminal value at this point, and which is given by this, right, at year 3, right? Because if you recall, the growing perpetuity formula is 1 year from today. All right. And then after that, given that we have calculated at the point of year 3 what is the TV, the terminal value, then we have to discount it back by 3 years. So that's where this step 5 comes in. We have to discount back. So we have done the growing perpetuity here in step 4, given by this. Then we discount it by 3 years back, 1, 2, 3, to year 0. And that's where we got this. And what do? We simply add up the 3 cash flows that we have calculated. So we add this plus this. Yeah, that's correct. We are using D1. Yeah, that's right. So we are using D1 divided by, so it's the growing perpetuity formula. So D1 divided by it. I want to highlight to you, you need to be very careful and draw this line graph to see where are you standing, right? So in the sense of how many years do you have to discount the terminal value back. So this is very important, right? You know that you need to discount the terminal value back, but you need to be very clear where are you. Because in this sense, you know that your normal growth start in year 3. From year 3 onwards is normal growth, right? So that means you are standing at year 3, you use the growing perpetuity formula to give you back the terminal value to year 3. But after that, you still have to discount back the terminal value. So this is the part that usually people forget, to discount back the terminal value by 3 years. Because remember, at the end of the day, you are standing at year 0, right? You are not even year 1, because you are year 0. So again, I want to put three stars here that you need to discount back your terminal value, right? Everyone clear with this? Because this is an important step. And I'd say, like, as usual, you know, before I started the lecture, I say, like, understanding the three models is very important, because in the next lecture, we are going to use the CFF or FCFF, FCFE, and we are going to go back to this formula, but they are more complicated because we now need to calculate how to get the FCFF, how to get FCFE, etc. Right? So everyone understand, right, that why we need to discount the terminal value back by 3 years. Anyone need me to repeat? Why do we do that? Why do we need to discount terminal value? Everyone's good. No one need to repeat. Okay. Okay. So this is the simple 2-stage. At this point in time, yeah, that's correct, to get a PV. At this point in time, you will see this generic formula here. Okay. And the thing is, what is this GS, GL? What is all this? Is basically given by this GS, GL. So S is the supernatural growth, and GL is the low growth, right? And just want to let you know, this summation is your sum of PV. PV, you can see here, is the sum of PV here. And this component here is your growing perpetual, GP. Okay, so you can usually use this generic formula, but my recommendation is to understand how to do it in the sense of this method here. Understand how to do it like this. Use this method instead of using the generic formula, right? Why? Is because sometimes the generic formula is being written in a form that is so simplified that it's very hard for you to figure out, right, what is what. We know that these two components here is sum of PV and this is GP, but sometimes you look at what's the N, then you will think, oh, what's the number, what N should we put? Should we put year 2, 3, 4, like what's N, right? But hope you know that N is usually the year where the supernatural growth stops and go on. So like in the previous case, N was to 3 here. Okay. And this is a sum. So remember, you need to have 3 components here. So because it's a summation, it's a summation of 3 cash flows, right? Sum of PVs. So you can use the generic formula, but I highly encourage you to understand it and use what we have done in the earlier slide. So method 2, remember I said there are 2 methods. One is using the sum of PVs, or you use a growing annuity. So I'd like to show you the growing annuity one. Why this is important is that sometimes the number of cash flows can be a lot. perhaps it can be growing for 10 years, and then after 10 years, then it drops to normal growth, right? So in this sense, okay, if you have your Excel with you, that's fine. 10 years, you simply drag the formula. But in the case you do not have Excel, or by whatever means, you don't have a computer, you need to manually, in the sense of using a calculator, especially those who are interested in doing the CFA, of course you don't have Excel, then you need to use this growing annuity formula already. So you need to know that, actually, you know what? You can actually use a growing annuity, and this is what we're doing here. So I put a small recap here, what's a growing annuity formula, and what is this growing perpetuity. Just a small recap. But let's look at the question again. Very simple question, very similar to what we saw earlier. We have a current dividend, D0, of $2. The growth is for the next 3 years for 15%, high growth at 15%, long-term growth at 4%, required rate of return is 10%. Right? So for the first 3 years, it's going to grow at 15%, and therefore we can use the growing annuity formula given here. Right? So I basically plug in the various value, C, and remember for the growing annuity formula is the same concept that it uses D1 and not D0. So you use D1, where you take 2 times the growth rate of 15%, you plug in R minus G, you put the various value here, 1 plus G, 1 plus R, and then you calculate simply the PV of the dividends for first 3 years. Now that you have calculated this, we need to find what is the dividend value at year 4, right? Remember the line. I'll not draw the line, but I'll just flip over. Remember this line here. You need to calculate what's year 4. Okay. So we calculate what is the dividend value at year 4, right? So we know that we grow at 15% for 3 years and 4% on the year 4, right? This is to calculate the D4 or the D1, or in the sense to use this D4 for the growing perpetuity formula for the stable growth stage. Last but not least, remember I mentioned that you need to PV back your TV, right? To repeat, to present value your terminal value, right? PV of TV by 3 years. And you get this. And then now what we do is we just add them up together. Total valuation. And I want you to notice something here. You notice that the TV contributes majority of your valuation, right? And so that's where we go back to what we mentioned earlier, that in a valuation using DDM, using FCFE, FCFF, there is very high emphasis on the growth factor, but not only so, but on the terminal value, right? So you need to really estimate the growth properly. Any questions regarding method 2 using the growing annuity? No, very good. Okay. So there's a bit of critiques, of course, for simple 2 stage, as you already noticed, which company suddenly dropped the growth from 12% to let's say 5% overnight, right? So this drastic drop, it doesn't make too much sense. Overnight drop like this doesn't make sense, and therefore we have the H model. Whenever we talk about H model, so the next topic we're going to think about is this H model, where the growth declines gradually. Okay. Of course, there are some assumptions in your simple 2 stage as well. Dividend payout and risk remain the same. And of course, sometimes it's also very difficult to estimate, because remember, at the end of the day, we're doing valuation, right? We are estimating. So how do you know, like, oh, this company is going to grow at 12% for 5 years? Why not 3 years? Why not 4 years? Why not 3.5 years, right? So sometimes it's very difficult to estimate the number of years of growth, high growth, or until you drop to normal growth, right? So these are some of the struggles, and sometimes it differentiates a star analyst, an analyst with experience that really know how or how to put in these kind of assumptions, right? So, oh, okay, I estimate the growth with 5 years and instead of 4 years. And of course, this comes with experience. Why 4? Why not 5? Right? So, of course, in a question, in an exam question or in a practice question, this is not something you typically bother about, right? Because the question may tell you it's 4 years. But in real life, usually this is a important component that differentiates a good analyst and maybe a new analyst. Okay, so at this point of time, I think we should take a break. Maybe let's do like a 8 minutes break. We come back at 7:08. Not 7:08, sorry, 8:08. Before we move on to the H model, where it's a gradual decline. All right. So let's take a quick break. If you do have any questions regarding break, feel free to put it in the group chat and we'll reconvene in a bit. All right, welcome back. Have a good break. So, let's continue on to talk about the two-stage, now the H model. All right, and again, to mention the H model basically simply tries to model the gradual decline in terms of the dividends. So the decline goes from G plus or GS, G supernatural, to G low, right? GL or just G. And what is this H? So H equals to number of years to reach sustainable growth divided by 2. Okay, so do not worry, we'll look at an example later and see what does this mean. The important thing to take note is that the H model is a approximation model or approximate formula. Means that it's actually not accurate. And it depends on a few things. First of all, that it assumes dividend payout to be constant in both stages, as we saw in earlier the simple two stage as well. But not only that, because it's an approximation, it only works if H is small, meaning what? Meaning the supernatural growth is for like maybe 5 years or 4 years, a small number, right? So H is small, and the difference between G and G plus and G is small as well. And we'll see why in a bit. Okay, so again, I repeat, this is an approximation model. So this is me trying to explain to you this model that we see here. Okay, so in a H model, we know that it looks like this, right? The two-stage H model. It gradually drops. So why is it approximation model? First, let's look at this formula here. All right, this is a generic formula. Anyone can remember what is the formula for a triangle? I think everyone should know this. How do you find the formula of an area of a triangle? Yeah, correct. Half base times height. Perfect. Yeah, that's right. That's right. So what we're trying to do now is we're actually finding the area under the graph. Okay, so again, I repeat, this is an approximation formula. And what we're doing here now is we want to find what is the area under this graph here, right? The whole graph. Okay, let me just erase this, but you get what I mean, right? So in a sense, we want to find the area of, number one, this colored triangle, plus the area of this rectangle, right? And we know that this rectangle is quite easy to find, right? This rectangle is a, what is it? What kind of formula can we use for this rectangle? Base times height. Yeah, correct. Base times height. And this base times height, it is like what? It is a stable, it's a stable growth, right? Stable growth, and it gives the GP, right? Growing perpetuity. So it is like this, remember this thing that we saw earlier? Just like this. It's just growing perpetuity, right? So this is a growing perpetuity, and it is what we have here, okay? So, and it's what we have here, growing perpetuity from year 0. So this is the first component of our formula, right? So we have tackled the rectangle, which is base times height, which is basically this growing perpetuity here. So we have tackled this. Now, how do we tackle the triangle here? Because remember, at the end of the day, the objective is to find the area under the graph. So in a sense of this triangle, and you mentioned half base times height, let's just write the formula here. So half base is what? Base is H, right? I mean, depends on which you treat as a base. So let's say this is the base, this is the height here, okay? So half the base is what? GS minus GL times height is H. Yeah, that's right. So base is, yeah, we can do either way. Height and base can flip over because it's a 90 degrees triangle. All right, so we see this formula, area of triangle, half times base times height here. Now, I want you to just compare. Okay, before we compare, let me just rewrite this here. Half h gs minus gl. So I just shift the h. All right. Now I just want you to compare. Let's ignore this. I'll just cancel out this. Let's just look at the top here. Here. Can we compare this and this? It looks quite similar, right? Can you see that gs minus gl, gs minus gl? And remember what is h? Okay, so I'm going to flip back to the last slide. What is h? H is defined as number of years of sustainable growth divided by half. And what do we have here? Half in the triangle formula, half h, right? Half h equals to, so the h in this formula here equals to the half h based on this h here, right? Okay, it's a bit confusing, h, but I should have used small h. Yeah, but everyone can see that the h equals to the half h, which is given by what is given here. So h equals number of years of sustainable growth divided by half. All right. So of course we have to add the dividends component, right? So the dividends. Okay. So everyone got the triangle component. Yeah. Yeah. So you take into account the half. Yes, correct. So that's why going back to the last slide, what is h? H is defined as number of years divided by 2. Okay, so yes, the h in this generic formula takes into account the half. And we'll see the use of this generic formula in a bit so that you can understand how to use it. All right. Now we have understand the area of the triangle now, right? And so going back to the below component, why do we have this d plus d naught divided by r minus gl? Again, it's the same thing because we have the growing perpetuity, right? So that's why we have this. So in this sense, okay, everyone understand the triangle, right? Area of triangle. So I'm going to erase it so that it's easier to see. Okay, so I'm going to erase now. Huh? Okay, so as the slides mentioned, so this portion of the formula is the triangle or at supernatural growth, and this portion is the area of the rectangle, which is the growing perpetuity, right? And generally we use we can combine them because the base are the same. We give you this, is no difference, it's just the same thing. And so we use this approximation formula to calculate H model, right? So there is now, if you realize, no so-called exact method to calculate this approximation. Right? Again, I want to highlight in this formulation here, in the generic form, H equals to number of years of sustainable growth divided by 2. Okay, this is the formulation. Okay, so we do have a question here to help you understand how to use this two-stage H formula. So let's look at the question again. I want to highlight that and encourage you to draw this graph whenever you are given a question, because that's important for you to visualize, and typically the question will not give you the graph. I drew it to assist the understanding. All right, so we have this question. Earning, again, there are quite a bit of information. They say earning is 50 million, number of shares outstanding is 5 million. Earning growth at 20% for past 5 years. So this is a supernatural growth, right? GS. It is expected that the growth will be sustainable rate at 8% starting from year 5. So from year 5 onwards, it's going to be the normal growth, right? At 8%. And the thing is, it will decline linearly every year, right? From the current 20% to 8% in the 5 years. So we know that now we're doing a question on H model, right? Because we are talking about linear decline. Dividend payout ratio is 60%. Oh, that's nice. They give it to you. Risk-free rate is 4, risk premium 7, beta. So all these are basically your CAPM, right? CAPM information. And we know this is used to calculate your return on. All right. So now we know a general formulation for your H model, which is given by this. There's a small little recap here. And we can calculate what is your dividend payout ratio, right? Okay, again, we do the same thing. We do the EPS, we do the dividend payout ratio, and we know that the amount of dividend paid out is basically just your EPS times the payout ratio 60%. So we pay out 1.8. So the question is kind of similar to what we saw earlier. We calculate what's the cost of equity, which is given here, using a CAPM model. Now, we are using the, now we are plugging in the values into the approximation formula for for the H model. And so the D naught, so in this formula, we use D naught. Please be very careful. In the formulation is D naught plus 1 plus G here, okay, plus D naught times H. So what is H? Remember, H is half of the number of years where it's a supernatural growth, right? So supernatural growth is 5 years. So what is H? H, we just take 5 divided by 2. So this is an important part, 5 divided by 2 here. So that's a H, which is given by this H here. Then we take supernatural, 0.2 minus 0.8. So this is the component of a based on this formula. And then we take R minus GL, which is given by here, and this will give you V naught, which is the valuation of your the company using the H model. So if you notice, actually the H model is quite or questions regarding H model is quite easy because you just use this approximation formula. But the reason why we went into so much detail about the H, the approximation formula is so that you can understand where it's coming from, right? So I want to highlight to you that remember this component here is your GP, growing perpetuity, and this component here is your gradual decline, right? The triangle that was declining. So there are two components here. All right, any questions regarding this example that we have here? So, probably a broken record, but remember the H is half the number of years of the supernatural growth, right? So it's 5 divided by 2. Okay, so if there are no questions, so let's just look at some strengths and weaknesses of your DDM. It is more of this theoretical kind of information. So it's useful for evaluating stable growth, company. It's generally used for valuing broad equity indexes. Let's say relationship. So this is so basically you just need to know what is the relationship between the return on equity and the payout ratio. So this is basically just saying that, if the company is paying dividends, then we can estimate the value of the company. So just some information. Weaknesses, something that we mentioned a couple of times already, is very sensitive to the growth rate, right? We talked about this and we saw how the growth rate affects the terminal value and where most of the value or valuation of a firm for the DPM comes from the terminal value component. It's not applicable to non-dividend paying stocks. We know that, of course, you can't use. If non-paying dividend, you can't. It's not applicable to unstable stocks because you notice that in the 3 different type of models, or you can consider 4 models that we see, it's usually quite stable, right? It's either no growth, stable growth, or like 2-stage growth, but it's all very stable. Even the gradual one is approximation, but at the end of the day, it's a stable kind of growth, right? So if it's unstable growth, you cannot use the DDM. Not applicable when the growth is higher than rate of return. Why? Because we are, remember, in the growing perpetuity, we use D1 divided by R minus G, and if growth is higher, this formula doesn't work. So you cannot use it. Some applications, company, of course, have to be paying dividends, no negative earnings. Why? Because if it is earning negative earnings, it typically will not pay out dividends, right? There's no earnings, it's making losses. Why should it give dividends? So, yeah. At the same time, it should have a consistent, the dividend payout or dividend policy should be consistent with the profitability, right? In a sense that it shouldn't be like, oh, it's making losses, the company is making losses, but they're still paying a lot of dividends. So that, because if it's like this, if you see a company like this, then maybe you shouldn't use the DDM model, right? Maybe you should use the free cash flow, maybe to firm, right? Because we should consider, let's say, the debt component of the in the valuation, because perhaps the company is using the debt to pay dividends, right? Because first of all, it's making losses, but it can still pay dividend, meaning that they are using actually money from the debt they raise to pay dividend, which is not sustainable. And of course, we use dividend discount model if it's hard to estimate cash flow. And we'll see why it's so difficult to estimate cash flow in the next lecture, because there's actually many components to estimating cash flow, right? And that's the focus of the next lecture. And of course, dividends is very obvious, right? We just go to an annual report, you see the dividends, we can just estimate. Okay, I think we do have a question. Let's see. Okay, so we have a question where if the company has a dividend policy aligned with the profitability, but is an unstable growth, so what do you do? So, because what we have learned so far, in the dividend model is kind of, I would say, very perfect situation, right? Where it's like, oh, it's high growth, low growth, and then that's about it, right? Or it's gradual growth. Obviously, you know that in real life, it doesn't work that way, right? Most of the time, growth can be 5, 4, 1, 2, etc. So what we can do is, if it's an unstable growth, either we do an approximation meaning what? We remember how we calculate growth. We can use historical. Remember there was this slide where you talk about calculate the average growth, right? So we use a historical, we calculate average growth. Perhaps, let's say, that's a good question. Let's just give a hypothetical situation where the growth at a high level is like, let's say, 11%. Okay, always a percentage. Okay, let's put 11%, 12, maybe 15, 9. So this is the high growth level, right? And then we have the lower growth, maybe it's 5, 2, 1, 1, right? So these are 2 groups of growth levels, and they are quite unstable, right? But you see that there's 2 distinct groups. One is higher, right? And one is lower here. So we can try to think about it in a sense of maybe this is a simple two-stage. So you find what is the average growth here, take that, maybe you a simple average, and then we calculate what's the simple average here. So this is your GS, GL, and then we use the simple growth model, simple growth, right? So that's what we can do in the sense of doing like a approximation if there is unstable growth. Of course, this is like quite real life, right? Because growth is never like constant at, let's say, 12% for 5 years. It's never the case. Okay, so I hope I answered that question. Earnings. Okay, let me just erase this. I think there is a question on earnings. This. Okay, so when we think about earnings, we can see the profitability. So we are talking more of the net income level. Yeah, we will refer more to net income. So generally, for your dividend payout policy, they typically based on your net income. So higher net income, the policy would usually say, oh, you pay out more dividends, right? So yeah, usually it's net income. I want to highlight that you in the annual report, all right? So annual report, if you're doing a valuation of company, I encourage you to look at the notes to financial statement on the dividends component if you're using a DDN valuation. Because most of the time in the annual report, they will actually mention in the notes on the dividend component how they actually calculate dividends, right? And then they'll have, sometimes they even mention what is the dividends policy. And that's where you will know, okay, their dividend payout is based on what. So it really depends on how the company structured. Sometimes, remember when we were talking about last lecture, when we talked about dividends in general, remember there are a few ways companies pay out dividend, whether it's based on the profitability or is it based on percentage. They always pay out 30% of their net income, or is based on a fixed amount. So they always pay $5 per share, right? Fixed regardless of what. So there are various methods of paying dividends. Okay, so let's see a question. Can we see the growth rate? Growth. Okay, so you're asking about earning growth rate. You're not asking about sustainable growth rate, right? Because those are two separate things. So if you're talking about earning growth, then we just look at the change in the earnings and we take the percentage change, right? What's the growth? Remember, earning growth is different from sustainable growth. Yeah. I hope. So don't get that mixed up. So when we use the G, when we use the G for our perpetuity and all, those are based on sustainable growth rate. Could the earning growth be equal to sustainable growth? Let me just. It could be, because remember, okay, that's a good question. Can the earning growth be equal to sustainable growth? Remember, sustainable growth G equals to B times ROE, right? So I'm just using mathematics to try to answer your question. So when you talk about earning growth, right, we can actually, let's assume that return on equity. So remember, what's return on equity here? Return on equity is net income divided by equity, right? And so if we, typically equity amount kind of remain more or less the same. It doesn't fluctuate like every year, it increased by 1 million, decreased by 2 million, because the amount of equity is there, right? Usually it's very paid up equity, so it's there. So what happens? What's happening now? The question you're asking is, can the growth of net income, right? Net income here be equals to the sustainable growth here? G here. So if you say that, if we assume that equity remains constant, this remains constant, what happens? It means that if B equals to 1, right? If B equals to 1, then your sustainable growth can be equals to your growth of net income. All right, I hope I answered that question. And it means what? If B equals to 1, it means retention ratio equals to 1, means that there is no payout there's no dividend payout, right? Because remember, B equals to 1 minus payout ratio, means payout ratio equals to 0. So it is a very hard assumption to make to say that sustainable growth equals to growth of net income. I think it's a bit a stretch unless you can really prove it and say that it is, right? But I wouldn't make that assumption because that is very hard. Can you say that dividend payout ratio equals to 0? That is the tough part. Okay, just be very careful with that. Okay, we have a question. Valuation model does not agree value stocks like Tesla due to high growth, negative earnings. Okay, that's true. Negative, especially negative earnings. But due to okay, that's a very good question. So the question is Tesla, we have high growth but negative earnings. And this is very typical of a startup firm, right? So usually startup firm, super high growth and negative earnings, right? Because they are not making money yet. So what do you do here? So dividend discount is definitely not the model you want to use, right? I wouldn't use dividend discount at all. But you should consider using free cash flow to equity or free cash flow to firm, right? Free cash flow to equity if you are equity investor, and free cash flow to firm might actually be better method because you want to consider the amount of debt the company takes on. Remember, one of the conditions to use free cash flow to firm, free cash flow to equity is that the leverage structure is stable. Now, if it's an unstable leverage structure, which I'm assuming in Tesla, it could be because it is growing, it's still like more like, I wouldn't say it's like startup, but it's still growing rapidly. They are taking a lot of debt, they are doing a lot of debt restructuring and all. Then maybe we should consider the free cash flow to firm by considering what is the amount of debt that affects the cash flows. So I hope I answered your question. So we should use, of course, not the DDM, but we should use the free cash flow to firm or to equity model, especially for negative earnings. Because negative earnings, then there's no point looking at earnings, right? We should look at cash flow. Because remember, cash flow and earnings are different. And I hope you still can't remember how to calculate free cash flow. We will do a in-depth question and analysis in the next lecture. But if you refer to lecture 2, we did talk about a couple of formulas, right? And we know that earnings and cash flows are totally different things. Yeah. So usually a negative as purely on earnings, but because of that, that's why we have the cash flow model, which actually in the industry, most people use the cash flow model instead of the dividends discount model. Because the dividend discount model is a bit too simple most of the time. Okay. So going back to this, the question regarding the assumption of growth, earning growth equals sustainable growth. I want you to be very careful when you make this assumption. So earning growth, most of the time cannot be equal to sustainable growth because you are assuming the B as to be 1, which is very, very unlikely. So unless you are very certain, then you can make this assumption. If not, if you make such assumption, it's kind of wrong. It's like very obvious that it's wrong. Okay, all right. Those are very good questions. Yeah. Okay, so dividend value application. There's just a bit more theory. Valuing non-dividend company estimate. So if it's a non-dividend company, generally we just avoid using the dividend discount model, right? Or if you want to use a dividend discount model, what we can do is let's say we try to estimate the timing and amount of dividends of a company that's quite similar, right? Maybe use the industry average for dividend payout ratio for that company. There are several also, of course, alternative stream where I mentioned residual income or cash flow, which is usually preferred. So we shouldn't even bother about dividend discount. And last but not least, we can use this thing called the relative valuation method, which we'll talk about it, I believe, in lecture 6, the last lecture, which is an important method as well, relative valuation. All right, so valuing companies' negative earnings. So if again, that was a good question, negative earnings, then you know what? Maybe we should use the free cash flow models, FCFF or FCF, right? Cyclical earnings as well. Maybe we just use the cash flow models. Or what we can do is like what you mentioned, you do an average, apply averages. So this is just some general rules, when is the DDM suitable, when the company is paying dividend, when dividends related to the company profitability. Remember, we talked about having a dividends policy, right? And at the end of the day, I hope you remember this, that you are valuing a minority stake in the company, right? What does this mean? It means that if you are a minority stakeholder in the company, you are actually more interested in just getting dividends, right? You are not going to make any major decisions. You are not making any M&A decision because you have no power, right? And what you're interested in perhaps is just, I just want to get dividends. I'm just a small shareholder, and also you just want to calculate the company's valuation based on the dividend because that's what you're interested in, right? Getting the dividend payment. And yeah, and I guess if it's a no growth company, 100% payout as dividends, and yeah, you're just interested in that sense, right? Okay, so now this is just a very I would say very simplistic kind of example just to illustrate what we have talked about, right? So which is DDM suitable for OXY or HRL? Okay, so you have a question, is it the current investor? So remember at the end of the day, what is the purpose of the whole course in general, or why even learn all this detail? Remember, we are trying to value a firm, right? So now you need to think about yourself as the stamp, as an analyst valuing a firm. Who are you valuing for? Okay, let's say if it's a personal thing. So you want to invest in a stock. Let's say you invest in Tesla. It's your own personal investment, right? And we know that, of course, we don't have billions of dollars to buy like what 10% in Tesla or whatever, right? So the thing is, because of that, we know we're going to buy like, I don't know, 10 shares or I don't know how many shares, right? And we know we are a minority stakeholder if we decide to invest in Tesla. And therefore, because of that, maybe for us, if we are just a retail kind of investor, using DDM is good enough, right? We are a minority stake, we just value it using DDM. However, the thing is different, right? Let's say now you are representing BlackRock. BlackRock, if some of you know, or if you don't, is a very big fund investor, right? They invest in major companies, right? And like BlackRock invest a lot in technology firms. And the thing is, when they invest in technology firms, they can put billions of dollars into this firm for investment. And because of that, perhaps their purpose is no longer simply just for a minority stake. Maybe their purpose is to, do restructuring of the company, etc. And therefore, what they're interested in is not the DDM, not just getting dividends, right? It's more on the cash flows, right? And usually for big investors like this, they want to do the FCFF, sorry. So free cash flow to firm, right? Because they want to see what's the cash flow that is being available for the firm at firm level, including debt holder and equity holders. So it really depends on your purpose of the valuation. Yeah, so DDM is not suitable in the case of BlackRock. So if you are an investor, I mean, you're not an investor, but if you are like an analyst in BlackRock and you are looking at investing in Tesla, generally, no, DDM is not a model that they will use. Maybe they will use it simply for checks to make sure that the valuation, their DDM valuation, not really DDM, but their FCFF valuation is somewhat close, not very close, but somewhat similar in some ways to the DDM, right? But of course, there are a lot of assumptions they have to make, like, oh, maybe, I don't know, yeah, various assumptions made. Somewhat close, right? Not like super different. But generally, they will not use the DDM. Yeah. So in this, yeah, thanks for the question. So in this example here, if you had some time as we were discussing the other stuff, just some time to look at, first of all, the EPS and the DPS, earnings per share and dividends per share. Let's look at this one first, right? Let's look at OXY. Again, I want to highlight that this is a very simplistic example. There are a lot more details that you need to consider, not just looking at the fluctuation, right? But this is just a very simple example. In real life, we don't just see, oh, it fluctuates like this, we kick out DDM straight away. No, we don't do such thing. We need to really read the company's statement, what's their policy, what are their leverage like, what is their growth strategy. Remember all the qualitative stuff that I talk about. We need to consider all those before we even say, oh, DDM is out of the question. All right, but this is a very simple example to illustrate the points that we talked about. So what we notice here, can we see something that is peculiar? We see that they pay out dividend per share of $1 throughout, regardless of the earnings per share, right? When they are making a loss, they still pay $1. They are making a gain, they still pay $1. So in this sense, there is actually no policy, dividend policy relating to the profitability, and hence DDM is not good, not a good valuation method. However, if we look at HRL, right? For HRL, we see that, okay, when EPS is high, the dividend tend to be high, right? In this sense, I'll recommend to plot a graph to see the trend line, but it seems like it, right? So you can see EPS is this, they pay out this dividend. But when EPS is high, 1.3, they kind of pay more dividend, right? Although not all the time as well. If you notice at some points in time, the EPS and dividend kind of doesn't match. So in this sense, DDM is a better option. But at the end of the day, again, I want to put a big disclaimer that while it might seem like the case that OXY is not so good for DDM and HRL is good for DDM, this should not be the only determining factor, right? We need to consider a lot of qualitative factor that we talk about in lecture 1, as well as look at the company's annual report and look at their dividend policies. So actually, yes. So remember, one of the conditions is that the payout ratio should be stable, right? Remember, we look at it, one of the conditions. Yeah, so if it's consistent, that is tend to be a good candidate for DDM. Yeah, it should try to be consistent. All right, so I believe this is the end, but what we're going to do is we do have time. So I want to go through two examples in your self-review. One example is the H model. So in this self-review, which you can do next week, because there's no lecture next week, there are a lot of questions. I highly recommend you to do or practice as many questions. The solutions and numerical solutions are given to you. If you do have any questions regarding the workup solutions, feel free to email me. If you like, for example, question 2, you tried many times, you ask your friends, you couldn't even get answer, then reach out to me. But of course, as you know, the new structure is the alternate week is that the in-between week is kind of where you kind of do like group learning and all. So I encourage you to practice the questions. If you can't get the answers here, then email me, but try to ask around your friends first. So there are quite a lot of questions. And they are very good practice questions, I would say. So we're going to take a break, but I would like to, after the break, we are going to go through two questions. Question 13 here, and question 14, which is the 3-stage and not in the syllabus. But I want to go through this because it's a good, I would say, good foundation to really understanding the stages of DDM and how you break them down into various stages to analyze the valuation, right? So this is more, although it's the 3-stage, I want to repeat again, you'll never be asked to do it, the calculations, but it's a very good way to understand, make sure they understand the valuation, right? So I'll go through question 13 and 14 after the break, right? Let's come back and let's say 9. Let's come back at 9, all right? And you do have any questions, feel free to put it in the chat. All right, so welcome back. Cool, let's go through this question on the H model, and we can see how questions are written and understand how should we tackle such questions. All right, so let's see. So we have a portfolio manager here, managing a US-based diversified global equity portfolio. Okay, they want to research valuation of Vinci, the world's largest construction company in France. Okay, there's some information. Since 2004, he has paid 2 dividends per year, an interim dividend in December and a final dividend in May. Although during the past 5 years, annual dividend growth, okay, this is important, for 5 years, annual dividend growth has been 26%. And the portfolio manager foresee a less rapid future growth, right? So we expect a drop to normal growth. Having decided to compute the H model valuation estimate, okay, so they already tell you that they want you to use the H model. He gathered the following facts, right? So they are given the following information. So share price of as of the middle of October is this. We are given a share price. Current dividend is 1.37. They give you current dividend. Initial dividend growth is 2.4%. Okay. And it will decline linearly during the 12 years period to a final and perpetual growth rate of 6%. So there's going to be a decline linearly. Required rate of return is 10% here, right? So in the usual fashion, I would usually like to encourage you to draw the graph. All right, so we know that the decline is going to be in year 12 for 12 years. All right, we start at an initial growth of 24% here, and we drop to the final growth of 6%. So once we have understood this, let's see. Using the H model, estimate the per share value. Okay, let's do part 1 first. So part 1, we have known that it's already a H model. We can use the H model formulation. And we just plug in the values, right? So D naught, what's D naught? So D naught was given at current dividend of 1.37. Okay, 1.37 plus growth rate of 6% at G low rate. GS, we know that is 24, as we have drawn or written on your graph. So 24 and 6. So basically, you just plug in the formulas. This is kind of easy. And the H, remember, is half of the total supernatural growth, right? Which is 12 divided by 2. So 12 divided by 2, sorry, that's 6, equals to 6. That's how we get the 6 here, right? H of 6. And we get this. Okay. Remember, the formulation is this component here is what? Is your rectangle, right? Your rectangle, and this formulation is your triangle, right? Remember, there are 2 components that we talked about. So your rectangle is the component that is the growing perpetuity, and your triangle is the declining supernatural to normal growth. Okay. Now let's look at part 2. Estimate the value of the share if normal growth period begins immediately. Now, we do not need to actually recalculate it. Why? Because if normal growth occurs immediately, we know that, what does it mean? It means that it's just going to be flat, right? Normal growth, stable growth, which equals to the rectangle. And what is the calculation for your rectangle? It is this. 36.31. So that's the answer. Rectangle. Yeah. So estimate the evaluate whether the share appears fairly value, overvalue, or undervalue. So we know the share price is 57 euros. Let's see what do we get. We get a 73.3. So this is a undervalue, right? Because it's lesser, right? Lesser than what we calculated. So you should buy this share. All right, everyone got this? So kind of once you dissect the question, kind of similar. Yes, that's right. It's an approximation. This is an approximation formula. Because again, this is a approximation. Approximate. That's right. Okay. All right. So question 14. Let's look at question 14 because I believe I feel it's a very good way to test your understanding on this division of the parts of the movement on the graph. Because at the end of the day, the 3 parts, it can be a four stage, 5 stage, 6 stage. It can continue on, right? There can be many stages. And of course, the more stage you have, the more accurate your valuation is, right? So that's why I want to, even though it's not in the syllabus, in terms of calculating, I think it's important to know how to calculate. Okay. So let's go through this question again. Now, so we do have a again the same thing, a portfolio manager, but now it's a small cap. This company is a headquarters in Alabama, diversified energy company involving oil and gas exploration. What else? It has natural gas distribution. Okay, fine. In light of the aggressive program to purchase oil and gas production properties, the portfolio manager, expect an above average growth for the next 5 years. Okay, so this is important, above average growth for the next 5 years. And he does a forecast as given here. Okay, so you have a current market price of this. So, okay, we are given this. Current dividends of this. Okay, fine. So he forecast an initial 5-year period of 12% earning. Okay. He anticipate that it can grow at 7.5% as a mature company. So this is the rate at mature, at like the stable mature rate. And allows for 10 years for the transition to a mature growth period. Okay, so these are important information. So you know what? Let's okay, so we have a few more points here. So we are given the CAPM details. Can just look at it. I'll not, this simply just CAPM calculating the return on equity. Nothing too exciting. And we have a security trading within a band of 20% to estimate whether it's a fair value as a fair value range, right? So this is quite typical. Usually you have a band of 20%, sometimes 10%, depending on how sensitive you want it to be. All right. So before we go to the first, there's 5 parts, quite a long question, but let's draw the graph as what we have done previously. Okay. All right. Let's hope that this space is big enough. Okay. So the usual pattern. Let's draw the graph here. Okay. So what's happening here? For the initial 5 years, it's going to grow at 12%. So let me use the color. Okay. Then it's going to decline, and then it's going to be flat, right? This is a 3-stage here. Now, first is at 12% for a 12-year. And this is for 5 years. So this is a G, this is T. Okay. What else? You know, at maturity, the growth is going to be 7.5. Okay, 7.5 at maturity. At mature growth. And the decline allows 10 years for the transition to mature. So what does this mean? 10 years means that this would be 15. So there is a 10 years period where it will decline. Everyone got that? Yeah. Good. You're following? Yeah. Okay. So you have 10 years for decline. Okay, so we have actually this is so, give me a moment. Let me just erase this. This doesn't look like 7. Okay, 7.5. Okay, we're all there, right? Everyone following, right? So now, first part of the question, we are asked for return on required rate of return. We simply use the CAPM formula. So this is nothing too exciting, right? Just CAPM. Okay. So estimate the value, part 2. Estimate the value of the share in a 3-stage dividend discount model with a linearly declining dividend growth rate at stage 2, right? Which is what we drew here, what we have drawn. So now I want you, okay, even though I think I've mentioned it earlier, you can actually break them down into 2 parts, right? Let's break down into this like that. So part 1 and part 2. This is a H model, right? And this is a PV of FCF, PV of cash flows, right? So you do a PV of cash flows for the first 5 years, then you use the H model after that for the second stage, right? Everyone can see that. So PV of CF and H model after that. So we're just combining the various models. Okay. So I mean, these are some description and all. You can read through them yourself. It's basically what I explained. So let's tackle part 1 first. Part 1 meaning the PV of cash flows, right? So let's focus on PV of cash flow. So remember, for the first 5 years, we have to calculate what's the PV. So what we're doing here, this is what we're doing here, PV of cash flows. So again, I want to repeat, you can, for PV of cash flows, you can use 2 methods. You can either do the growing annuity formula, or you can just do PV of cash flows, right? Using Excel. So we are given the, let me just flip back, D naught, current dividend as 0.46, right? Current dividends, 0.46. So we can calculate what's the PV of cash flows. We just, like what in the lecture example, we just multiply the growth, and then after that we PV the value using the required rate of return calculated with CAP. Okay, so we have done the PV of the 5 years. Now we know we need so this is part 1, right? So this is part 1. So part 2 is to calculate the H model, right? This is H model component here. Part 2, H model. So we are falling back onto the H model again, and we just do this formulation here, right? So we know what is D naught, but be very careful now, because your H model is going to be the terminal value, right? Because we know that I'm just going to flip back. What's this mean? Your H model is going to be a terminal value. It means that this component here is going to go on forever, right? Forever until infinity. So we know that this H model will have to be discounted back. Remember, we need to PV your TV. We're talking about PV or TV. So we need to PV back your H model, right? So you need to have that in mind. They need PV your H model. Now let's calculate H model first before we do the PV of H model. course, we do that, right? So we calculate what is your dividend in your dividend here, right? Your D5, which you just, because you know that it's growing at the supernatural rate of 12%. We just do it for 5 years. Okay. And you know your H model is given by your D naught times 1 plus G. And you know that the new G is 7.5, right? The new G, the GL is 7.5. So we are plugging in the values into your H model here, right? We plug in your values of H model. And we know that the transition period is 10 years. So we are going to transit for 10 years for decline. So H is 10 divided by 2 is 5. Okay. You know your GS is 12 and your GL, so GS being supernatural is 12% growth, and GL, which is low rate, is at 7.5, right? Which is what we have written here. I'm just going to flip over for you to just have a look. So 12, right? Supernatural, and oops, and 7.5 at low rate, GL. Okay. So we plug in the value for a H model, we get the valuation here, right? 42.1564. Now, remember, I say that you need to PV your TV. So what we're doing here, we are PV your TV. So we need to shift the PV back by 5 years, because like what we have done previously, we need PV your TV. So we shift it back by 5 years. And what do we do now? We just take this, part 2, this is part 1 here, plus it together. This should give you your valuation of 28.6044. Any questions for this? No. So again, I want to repeat that 3-stage is not tested in terms of such calculation. But if you do notice why I want to go through the 3-stage is that, can you see it's actually just utilizing the H model. So we have known the H model, and now because you know H model, we can actually do the 3-stage, and there can be 4-stage, there can be 5-stage. You just simply use the H model, right? So of course, the more stages you use, the more accurate your valuation will be. But you know, as all things, like all what economists always say, right? There's always a apex to the value that you get from doing more work, right? Yeah, you can keep on doing 5, 6, 7, 8 stage, but the value of doing so many stage would decline after a peak. So sometimes doing 10 stage, 20 stage might not be better than just doing 5 stage. Okay, so now you can see that, hey, actually the 3-stage is not so difficult to calculate. And I hope that you are able to appreciate that it's not really very tough. You just need to dissect the information carefully, understand each component, what you're doing, draw the graph at the start, of course, so that you're able to visualize. Okay, so I hope there are no questions, and if there are, feel free to put them in the chat. We have tackled part 2. Let's look at part 3 now. Calculate the percentage of total value represented by the first stage and second stage and third stage. By the first stage and by the second and third stage considered as a group. Okay, part 3 is actually quite simple, right? Because we have our various stages already. We know that the first stage is represented by what we have done here, right? What we have done here, number 1. And stage 2 and stage 3 is given by our H model, what we calculated here, right? So it's not so difficult. We just take the combination of PV of the cash flows divide by total, you get this, and then you just take 1 minus 8.5%, right? It's not very difficult. We just take 1. So we just basically take this 1, which is the combination of this, divided by this amount. And we take 2, which is given by this, divided by this amount. So we count. By knowing the various stages, it's not so difficult to dissect this information. Now, stage 3, part 4, judge whether the share is a undervalued, overvalued according to the perspective. So market price is 57.77, and what do we calculate? Total is 28. So is this overvalued or undervalued or normal value? But the thing is, whether it's over, under, we need to see whether it's within the security trading within this band of 20%, right? So we have calculated the intrinsic price as 28. So we need to calculate what is 20% above, 20% below, right? So they have done it for you here in the solutions. So 20% above, 20% below give either 34 or 22. So we know that our price trading in the market now is 57.77, which is above the upper band of 20% of 34.32, and therefore it is overvalued. Yeah, so in this question, they give you a range of 20% up and down, right? So it depends on, first of all, the question, but at the same time, of course, maybe in your valuation, when you do valuation, you need to also consider a band, right? Typically, it's not just above a certain value, because you know stock price fluctuates on daily basis, right? So we need to consider the daily fluctuation as noise. And so that is the reason why there is a band of 20%, because that would consider the daily fluctuation, which is not so critical when we think about valuating a stock. Yes, so we compare market price to a range. That is usually what is being done in practice. So in practice, nobody really compare a single stock price with a valuation that you have calculated, let's say using a 3-stage or 2-stage or 1-stage, right? No one that really does that, because we know that stock price fluctuates every single second, right? It doesn't make sense to say, oh, why do you choose that one tiny second, right? Why do you choose 9:23 a.m. as the right price to compare? Nobody really does that, right? You use a range to compare. So sometimes people use an average of 1 week, meaning 1 week in terms of daily fluctuations, and then they realize, oh, actually the price usually fluctuates 20% up, 20% down within a day, and therefore that's why they use a 20% band. So this is something that is, I would say, value add. You know, when you do your valuation report, this is quite a good value add. If you do a band, although I would say it's not very critical, but it definitely shows that you understand valuation very well. Okay, let's go to last part 5. So some analysts are forecasting essentially a flat EPS and dividends on the second year. Okay, only on the second year. Estimate the value of the share, assuming that the EPS is flat in the second year and 12% growth resume on the third year. Okay, so this is an interesting question. So what's happening here now? Let me draw the diagram here. Okay. So what's happening here? So the analyst is going to forecast that the second year is going to be flat. See what's the actual word they say? The second year is flat. Yeah, flat. Dividends per share. Okay, so it's flat. Flat meaning what? There is no growth, right? So what's happening here? For year 1, it's going at a 12%. Then it's going to be flat, and then it's going, and this is year 1. year 2. And then it's going to be go back to 12% again. Then it's going to decline and it's going to be flat. And this is at year 5 and year 15. All right. Everyone got that? So year 1, and of course this is year 0. And this one is 7.5. So at year 1, it's going to be 12%. Year 2 is going to be 0. Year 3 is going to be 12% again. And then year 12% until year 5. Then 5 to 15 is going to drop. Okay. So basically, it sounds a bit like, okay, so this looks like, wow, so scary, right? Yeah, correct. So the same concept is that you do the H model from year 5. So what we're doing here now, sorry. So for here, this component, H model, right? Then this component here, we do PV of cash flow. So exactly the same. But what's happening here? So for the first stage, right? For the first 5 years is PV of cash flow, right? So let's focus here, going back to PV of cash flow. Can you see that in year 1, it grow at 12%, right? Given here. Now, year 2, no growth. So the 0, right? So it maintain. But remember, you still need to PV back. You still need to PV the dividends in year 2. I mean, there's still dividends, just no growth dividends, right? There's no growth. Then year 3, it grow again, right? Year 4, it grow again. Year 5, it grow again, but all at 12%. Right? So that's the only change. But because of that, we know that the H model amount, the H model will be affected as well. Because the H model use the D5 times 1 plus GS. Sorry, I think it's GL, not GS. GL, right? G lower. So we know that D5 is how much? D5 is 0.7238. So use this 0.7238 plus 1 plus times 1 plus GL, and then you plug everything in the same. I want you to notice something, right? Your D5 here is this amount, 0.7238. Let's compare it with earlier. What's your D5? Your D5 is 0.8107. So basically, because of your no growth in year 2, your D5 has reduced in value. As you notice, right? 0.7 versus 0.8. And therefore, it affects your valuation as well, right? Yeah, makes sense. So your valuation expectedly would give you this for your H model, and your total, remember, I want to remind you again, when you, after doing your H model, you still need to PV your H model, right? Because this is a terminal value component. So you need PV or TV. And therefore, at the end of the day, what you should expect is that the total valuation should be less, right? Because your growth is less. So you add up your component component 1 here and component 2 from your H model, add it up together, get 25, which is less. Then compared to, let's compare this. This was given at 28, right? So you got less value, which makes sense, right? So sometimes, when you do calculation, it'll be good to also try to say like, hey, you know what? After calculating this, does this make sense? Like, is it lesser? And if it's lesser, then, oh, okay. Yeah, that makes sense. Because there was no growth, so it's lesser, right? Any questions on this change? And what you notice now is that having this model in your mind, there can be many variations, right? It can be no growth, or it can be no growth in year 2, no growth in year 3, then suddenly growth in year 4, and then maybe grow even higher in year 5. There can be many variations, but we just need to understand the basis of it, and then you plug in the values and try to understand how to dissect the information accordingly. Right, any questions? So this giant chunk of text basically is trying to explain this 3-stage model and the drop and everything. You can just read through it. Is what I was trying to explain or drop the explanation. So you can just read through it, right? Okay, so if there's no question, that's all I have for you. So we have went through solution question 13 and 14. I guess they are usually the tougher question. I highly recommend you to practice the first 12 questions as well. And you'll see the first few questions are actually quite simple. Then there are some H model, and for example, this question 12 is a bit more tedious, but it's not complicated. Yeah, okay. So sure. So if it's a general question, we can answer it for the benefit of everybody. So I think I'll pause the lecture here. So that's all for today. I guess there's no more questions regarding the lecture. Okay, so maybe before we answer some other questions not regarding the lecture, I just want to summarize. So today, basically, we just tackled the DDM valuation method, and we went into detail, right, on the various stages and steps, and the single stage, double stage, and three stages, right? And the double stage, we talked about whether it's a sudden drop, right, immediate drop, or a climbing drop. And again, I want to repeat that in the next lecture, we will do it with the FCFE and FCFF. However, the focus of that lecture will be more on how you calculate the FCFF and FCFE. And it assumes that you already mastered the various stages. So we're not really going into detail, or we need to segregate this and that, this and that, but we really focus more on how do you calculate the cash flow, right? Because the difficulty of the FCFF and FCFE is actually more on calculating the cash flows. So then we need to combine, of course, let's say the 3-stage with calculating the FCFE, FCFF cash flows. All right, so that will be what we're going to next week. Sorry, not next week, but the week after. And I encourage you again to, first of all, practice the additional questions. So there are additional questions in our tutorial group under the additional questions. There are no answers there, but feel free to practice it and drop me an email. I can look through your solutions, and if they are close, we can then if they're very far apart, then I can provide some feedback and solutions as well.